Hello everyone, I'm Sangol Semyafaba. I'm going to give a lecture on ohm amplifier for mobile charger. We have this circuit diagram. Circuit diagram for ohm amplifier, which is to be used for mobile charger. We have three main objectives, but there are a lot of objectives. But I suggest three main objectives, which is number one, as soon as I connect the external power, automatically it will disconnect the battery and supply the system. It will protect from overcharging, that is overcharging protection. And battery low and full charging indication. I will give a brief introduction about this diagram. We have DC supply of 12 volt, and this we introduce this circuit diagram. We have R1, R2, R3, R4, R5, R6, R7, R8, R9, which is resistor, and we use CA3130 ohm amplifier, and we use this T1 and T2 is diode, which is for T1 we use BC547, and for T2 we use BD677, and we have two gender diode here and two LED, and for output we'll get 5 volt or 180 mega ampere, which is ideal for an mobile charger. I will give a brief lecture on this topic. Most mobile charger do not have current or voltage regulator. Which often cause short circuiting. So using ohm amplifier to minimize this effect, we will use ohm amplifier in mobile charger. This charger provide 6 to 12 volt DC for charging the battery pack, but most of the mobile phone charger pack has a rating of 3.6 volt or 6.5 volt and 650 mega ampere. For increasing the life of battery, slow charging at low current is advisable, but 6 to 10 hours of charging at 6 to 10 hours of charging at 150 to 200 milliampere is suitable for mobile charging, which is good for our mobile also. The circuit here described in this circuit diagram provide around 100 and 180 mAh and 5.6 volt. So it protects the mobile phone from unexpected voltage fluctuation and develop on the main line, so the charger can be left on overnight to replenish the battery charger. The circuit protects the mobile phone as well as charger by immediately disconnecting the output when it sends a voltage surge or a circuit in a battery pack or connector. It can be also called as middleman. This op-amp can be called as middleman, which acts as a protector for both charger and as well as battery. It has features like voltage and current regulator, voltage and current regulator. Voltage and current regulator, over current protection, and high and low voltage cutoff. And added speciality of circuit is that it incorporates a short delay of 10 seconds to switch on, which man consumes following a power failure. It also prevents from power failure. This protects mobile phone from instant voltage spike. This in turn prevent instant voltage spikes. The circuit is designed for use in conjunction with 12 volt and 500 microampere adapter op-amp IC. Okay, CA3130 is used as voltage comparator. It is a BMOS operational amplifier with MOSFET input and CMOS output. In-wheel gate protected P-channel MOSFET are used to provide very high input impedance. The output voltage can swing to either positive. It can be either swing from either positive to negative side. The inverting input of IC1 is provided with a variable voltage of 10 to the wiper of voltmeter VR1. This one, VR1, and this is called as voltmeter. The non-inverting input pin 3. The non-inverting input pin 3 of this integrated op-amp is connected to 12 volt stabilized DC voltage development across Zener diode ZND1 that makes the output IC1 high. After power resumption, capacitor C1 provide delays of few seconds to a charger to potentially higher than an inverting pin 2. Yes, inverting pin 2. And of this ohm amplifier, thus the output of the amplifier goes high only at the delay in case of heavy power surge. Zener diode D1 will break down and short pin off at a point 3. The output of IC is fed to a base of NPN BD677 for the charging of battery, and the transistor T2 conducts only when the output of this amplifier is high. During the conduction, the emitter voltage T2, this one, emitter voltage B2, which is B6, BC54 and 547, is around 10 volt, which pass through R6, to restrict the charging current around 180 microampere. The Zener diode ZD2 regulates the charging voltage to around 5.6 volt when a short circuit occurs at the battery terminal of resistor R8. Here, and the R8 senses the over current, allowing the transistor T1 to conduct and light up the LED 1. Glowing of LED 2 indicates the glowing of LED 2 indicates the charging mode, while LED 1 indicates short circuit or over current status. The value of resistor R8 is important to get the desired current level to operate the cutoff. With the given value of R8 as this 33.3 ohms, it is 350 megaAmpere. Charging the current can also be changed, increasing or decreasing the value of R7, this R7, using the Ohm's law, which is V is equal to IR rule.